go.
All right, here's a vehicle that we've put together. It's a momentum cart on a Pasco track. We have the Pasco pulleys here, which are very low friction. And then we've got two masses. If you'll notice on this side, we've got a 200-gram mass here. And we have another 200-gram mass over here. So we have equal forces or balanced forces on this cart. Now, it's easy for everyone to understand that if it's at rest, it stays at rest. We call this static equilibrium. But what about if it's moving? This is one of the few instances we have of balanced forces. So if I start at one end and I have it move, you'll notice it moves at constant speed. Now it's slowing down a little bit because there's a little bit of friction, obviously. Okay? So we have basically constant speed. But what if we have no longer have balanced forces? If I add over here, I add a very small additional force. Now, if we'll watch, we have a positive acceleration. We call that direction positive. Now, if I push it the other direction, it will slow down. Well, we've got a little bit of friction issues here. Okay, let's add a little bit more mass so that we don't have that issue. Oh, the other mass fell off. That's what the issue was. It hit the ground. Okay, so we're going to go ahead and add 100 grams there, and let's watch what happens. Okay, and I caught it before it hits the ground. Now let me give it, let's call that a negative acceleration and watch what happens. So this would be an example, for instance, of, let's just call this a positive velocity with a negative acceleration. Or if you wanted to call that a negative velocity with a positive acceleration. And either one that has an additional force on it will be unbalanced and cause the acceleration to be that direction.